Discovery, go and throttle up.
What's going on, everybody? We're starting today with some launch coverage here. We have the Starlink Group 17-19 coming up here. What's going on? I'm EJ. I am the host of this stream. I'm keeping this stream afloat here. It's a good time. How's everybody doing? EJ's quiet. Oh. Yeah. Hold on. I'll fix it. Just chill. How's that? Are we better? That should be good now. Let's freaking roll, dude. You sound distant. Emotionally, maybe. What? Sorry. Anyway, so we're going to start today with some launch coverage. Starlink 17-19. Come towards the light. What's going on, YouTube chat? How you guys doing over there? So that should be going off in, well, about 7 minutes. The coverage should be picking up here. The stream should be picking up here about 5. Favorite NFL team? The Jets. I didn't see that. It's all good, man. It's all good. Clip it. It'll make Sawyer happy. You pronounced Seahawks wrong. I ain't scared of you. There we go. Coverage has started. Let's jump in. The red zone is for loading and unloading. There is no stopping in the white zone. The white zone is for loading and unloading. There's no stopping in the red zone. Gareth, how you doing? Doing good here. I was able to get even more ice chipped off of the driveway. My driveway, I can't see the ground. It's just frozen over, so, you know. I got that going for me, which is nice. We have, let's see, what's the high temperature in Massachusetts today? It's 22 degrees Fahrenheit. Feels like 16. The high is 23. The low is 5 Fahrenheit, which, okay. It is really freaking cold there, guy. You better freaking put on your jacket, dude. Ooh, dude, new synthwave from SpaceX. I haven't heard this one before. It's like picked the wrong day to stop launching Kerbals. Winter car vibes, yep. High is 15, low is going to be -5. Yep, you got me beat, Ordon. Not by much. Did I use the snowblower more today? No, it hasn't snowed in the past couple of days, but that's going to change over the weekend. The Poulan I did start up, it does work. And the Arians, that never stopped working. That never stopped working. She good. All right. So this is a Starlink 17-19 launch here. We're inside of 5 minutes here, so they should switch over to the view here. It is targeting. Oh yeah, there you go. See, I told you. So look at that.
Thanks for pressing for strong back retract.
This is Vandenberg. So this is Slick 4 East at Vandenberg Space Force Base. This is out in California. Vandenberg Space Force Base is right by Lompoc, California. It is about 100 miles or about 160 kilometers northwest, believe it or not, of Los Angeles. So you got that beautiful California, Southern California coast right there. Like, I'm telling you, man, there ain't nothing like that. Ain't nothing like that over here in the Atlantic, that's for sure. The Atlantic Ocean's a little more angy. Airplane's a great movie, P-Gamer, yeah. Are there more tiles on the fairing? It looks like there is, guys. So, what's, yeah, that same pattern, dude. Oh, no, the pattern is a little bit different this time.
Discovery, go at throttle up.
So, a little bit on this rocket. This is a Falcon 9 two-stage heavy lift launch vehicle here. Let's see. This is SpaceX's 595th mission for Falcon 9. 12th mission of 2026. And the booster flying tonight, today. I'm so used to Starlinks being in the middle of the night. The booster flying today is booster 1082 on its 19th flight. 50-day turnaround. It will be doing a drone ship landing on SpaceX's autonomous spaceport drone ship. Of course, I still love you. Looks like a Space Invader. Dude, yeah, I'm getting real Galaga vibes there. Let's see. So we're inside of 3 minutes here. The trajectory is basically a due south trajectory. These Starlink satellites are going to go into polar. So, yeah, straight polar launch here. Yeah, that fairing actually looks pretty new. So Falcon 9, I said, it's a two-stage launch vehicle. This is just in case anybody doesn't know this at this point. It's a two-stage launch vehicle. From about here down, that's the first stage. That part comes back and lands. It's going to land on a drone ship downrange, basically a landing platform, right? From here to here, that's the second stage. And the second stage engine is actually riding in this shell right here. That's called an inner stage because it's between the stages. It's hollow. It's a hollow ring, and then the second stage motor, the Merlin vacuum engine's actually in there. On top of that, you have two payload fairings. These are aerodynamic shells that protect the satellites, which are up here, right? SpaceX does reuse these fairings. They come back down and land. You can tell that one is cooked. Chat, are we cooked? No, only one of the fairings are cooked. Yes, I know I didn't use that exactly right. I don't care. Do I look 25 to you? No. So you can see that one of them is actually kind of scorched there because that fairing has been reused. The fairings do carry serial numbers that are down here on the rim of it, the end of the fairing, but I can't really see which serial number that one's carrying with this camera. It's only half cooked. Yep. Do you know what the weather constraints are for Artemis? I was about to say Artemis. Sorry. USA Space Enjoyer for Artemis 2. There's the ground gas closeout. evacuating all the propellants from the fuel lines, fuel and oxidizer lines on the pad so they don't catch on fire. That's what that vent right there is, evacuating liquid oxygen. It's turning to gas when it hits the atmosphere. Artemis 2, it's in the press kit. USA, we're inside of 1 minute. Vehicles go for start. Basically, it has to be pretty clear, and it has to be a pretty mild temperature. There are temperature constraints on the vehicle. Shirley, you can't be serious. I am serious. Don't call me Shirley. You only got to say it once, P-Gamer. Okay, launch director is reporting go on the Starlink 17-19 mission. Little to no wind. This is Vandenberg. This is Slick 4 East.
T-minus 30 seconds.
It used to be a two. The reason why it carries the East designation because it used to be a 2-pad launch complex. Now the other pad, Slick 4 West, is a landing pad for Falcon 9. 20 seconds. Pad deluge system should be on.
T-minus 15 seconds.
Okay. 10.
T-minus 10. 9, 8.
Sound suppression water system
6,
should turn on.
5.
There we go.
4, 3.
9 engines should ignite.
1. Engines full power.
Got 9 engines.
And liftoff. Go SpaceX. Go Starlink.
All right, we got a liftoff. Starlink Group 17-19 launching from sunny Vandenberg Space Force Base for a change. The loop is always a little bit off-spoiled. Alex is telling me the new fairing is serial number 243. Okay. How would he know? Because he's Alex. Why wouldn't he know? That's my buddy Alex over at NASA Spaceflight.
Vehicle is supersonic. Max Q.
Maximum dynamic pressures, peak compression load on the vehicle. Jono, you see it. You love seeing those hill ridges. I'm telling you, dude, Lompoc is beautiful. It is one of the most beautiful parts of the United States. I've been there. I've seen it. I've seen these launch pads. It is like paradise. This part of California, guys, so between like San Francisco and Los Angeles, think Amalfi Coast with less hills. That's what it looks like. It is just, it's just a beautiful part of the country. Untouched Coastline is the best. It's really nice. Yeah, she's performing a little bit of a radial out component, but this is what Alex and I are talking about. We've noticed that these Falcon 9s that have those Starship tiles on the side, they aren't rolling. So normally what the vehicle does, the rocket has orientation, right? There's up, down, left, right, forward, back. There's yaw, pitch, and roll. So usually Falcon 9 orients its antennas down towards the ground. Okay, there's Miko, stage separation. So think about it like an airplane. An airplane's going to take off, right? And the wings are going to be pointed towards the ground, and the top of the plane's going to be pointing up in the sky. If we think about orientation like that with an airplane, Falcon 9 usually rolls, so it's quote unquote wings down. There's no wings because it's a rocket, right? These Falcon 9s are not, when they launch, they're not rolling to their quote unquote wings down position. There's the fairing separation. These ones with the tiles are actually flying kind of sideways into space. They're flying with the wings quote unquote wings perpendicular to the horizon. So they're not, when they go up, they're not rolling like this, okay? They're rolling like that, and they're flying sideways into space, which is, it has to do with those. It has to be something with those tiles on there. The only, to a sense, that we've seen where it flies kind of sideways like this into space is a Starlink mission. It was the Starlink mission that was over the weekend. That's solid oxygen, in case anybody was wondering. It's not a rat or a bug. It's just a piece that's stuck there because of the drag induced from the camera housing, and it's gone. The interesting thing to mention here, guys, is that these Falcon 9s are ascending into space just like Starship. Starship flies sideways into space like this too, and then once it gets up into space, it rolls. So the Starship flaps are parallel to the ground. When Starlinks do ascend, or Starships ascend, they ascend with the wings perpendicular to the ground. Just something as to note. They must be testing cross-range flow on those tiles, which is very interesting. Dad, we got a bug. Yeah, they're flying knife edge. Exactly, Dan. Yeah. Philip Sloss did a quick talk on Space Coast Live. He wasn't sure exactly what the wind speed was as well for constraints, but should be go for tonight.
Discovery, go at throttle up.
Cool. Hey, SVO, tier 3, 35-month resub. 1 month till 3 years. Where did the time go? Feels like just yesterday we found each other. Dude, I remember the first conversation we had when you showed me you showed me 4-banger Mustang. And I thought that was the coolest thing, dude. Yeah. That was like last week. Bro, that was like last week. When you passed us on the freeway when we were towing the Camaro. That was last week, dude, right? Like, that was like 2 days ago. Yeah, how about that flyby? Yeah, exactly. Dude, that was like maybe a month ago. Like, wish it had fuel in the car. Dude, a lot of people cruised with us during that road trip, and that was really cool. That was really neat. All right, so we're getting up to my favorite part here, the entry burn. This is where Starship. This is where Falcon 9's first stage will fire its engines to slow the booster down, and also provide a cool envelope of gas to minimize entry heating on the vehicle. Because that first stage, she's going fast. It's got to slow down a little bit, and it's also got to make sure it doesn't burn up in re-entry. All right, supersonic retro propulsion. There it is. My favorite part.
Stage 1 entry burn shutdown.
Okay, so now as the Falcon 9 first stage gets lower, what it's going to do is you're going to start to see those waffle irons on the top. Those are hypersonic control surfaces. They're a type of control surfaces that's designed to steer the vehicle when you're going 5,200 kilometers an hour, right? You'll really start to see them do work as it steers that Falcon 9 first stage to its landing platform out in the ocean. Once again, the drone ship tonight is, of course, I Still Love You. I say tonight because Starlink always launches in the middle of the night. The drone ship landing today is, of course, I Still Love You. It's one of 3 autonomous spaceport drone ships, which are basically barges with oil rig positioning paraphernalia attached to them. It's like a kit bash barge with a bunch of other, they got other stuff on them too. Yeah, that's one of 3 that SpaceX has. Just read the instructions, and a short fall of gravitas they're on the other coast.
Stage 2 FDS is saved.
All right, now you're really seeing those grid fins do some work. Look at them shake around. Now, the staging velocity that we're looking for with this second stage on this trajectory is somewhere north of 28,000 kilometers an hour. So we still got some oomph to go with that second stage.
Stage 1 landing burn.
Correct, Vasia. Yeah, there's the drone ship. You can see it just on the left side of your screen, underneath the left grid fin. Stage 1 landing burn has begun. Grid fins are doing all the work here. And then when the vehicle's going too slow for the grid fins to do work, they lock into place, landing legs deploy. Falcon 9 is using thrust vector control on the first stage to bring that thing right dead center in the drone ship, and
Stage 1 landing confirmed.
We got a landing. 1082 completes its 19th mission. That's the 19th flight for that booster. Pretty cool. Now we should see staging once again. We're looking for somewhere north of 28,000 for an orbit like this. Staging velocity 28,559 at 137. That's a polar orbit. The reason why the polar orbit relatively is a little bit faster is because the stage has to use these are going to a little bit of a higher orbit, but also they have to fight the spin of Earth. When it launches, you have to negate the spinning energy that's imparted on the vehicle from Earth rotating. So you generally get higher staging velocities for polar orbits. Yeah, negating the spin is a real pain in the butt. You're moving pretty fast right now because you're on the planet that's spinning around like a giant jello mold. Repost to last. Why not test tile flow on the side of Falcon 9? They are. On the fairings. What do you mean, Coltec? The first stage? First stage isn't going fast enough. Yeah, it's not fast enough. The fairings are going to... They're not going to get you exactly what you're looking for. But once again, they're not... this is my personal theory. You know what? I should probably ask Alex about this. I think they're testing cross-flow over the tiles. Because once again, I told you about vehicle orientation. Like these vehicles are flying like this, right? Into space. And they're probably flying like that to make sure that the tiles don't get too screwed up aerodynamically. They keep them, like if the vehicle's ascending like that, they keep them on this side. So they're not aerodynamically turbulent for the vehicle. Because a rocket with a bunch of stuff glued to the side doesn't fly as good as one that doesn't, right? So they fly that weird trajectory up into space, but if this is the clamshell fairing, right? When the fairing halves separate, right, the outside of the fairing halves will reorient themselves and they'll go through reentry. And then those fairings deploy a parafoil actually, and they actually fly around and they land in the ocean like a seaplane, and SpaceX fishes them out. Now, once again, if this is the fairing when it separates, right, and the outsides of my hands are the outside of the fairing, the tiles are on the sides. They're not they're not here on this side of the fairing. They're up there on the side, like near the seam where the fairings separate from. So that tells me that, so the fairing's going to reorient, and when it reorients for reentry, the tiles are on the side of the dang thing, right? So that tells me that what these tests are is basically they're testing cross flow. So it's not necessarily how much those tiles or whatever can tank the heat. I mean, because we know they can tank the heat. They're pretty good at that. If you watched the Mr. Beast video the other day, he put his hand on the backside of the tile and he took a blowtorch to the front and he was fine. And the tile's about that thick, right? I think those tests are to test how plasma flows laterally over the tiles, because during the starships, right? If you look at this monitor right here in my mission control center, you see these tiles right here? Those are the tiles that they're looking to test here. They're testing how plasma flows over the tile that way, not like directly into the tile that way. If you can test flow laterally over the tile and figure out that you need a smaller tile there or no tile at all, just stainless steel, then you can simplify your thermal protection system on Starship. Those are definitely tests for Starship. They absolutely are, which is really cool. It's cool to see that prototyping, that SpaceX does. Do it? Nah, I'm good, man. Yeah, so we know SpaceX has also been experimenting with if we look at that Starship picture right here, they've been experimenting with where the tiles should end and where the stainless steel should begin. Even on Flight 11, we saw the tiles, this is an older flight. On Flight 11, we saw the tiles stop like right here somewhere. Like they've been really testing to see how far they can get away with, like taking more and more tiles off. And I really think they're particularly looking at crossflow over these tiles, because if those tiles, despite having plasma flying past the tile, can absorb the heat and protect it, then you might need less tiles there. I think that's why we're seeing it, I think that's super cool. But once again, the plasma crossflow over the tiles is just my opinion. I don't know why they're doing that test, to be honest with you. I don't know for sure, but that I'm making just a logical guess based off of what I know. They've also cleared the entrance to pad 2, which sure seems like a coincidence. Interesting. Why would they want less tiles? Weight? Yes, Kemp, it's not weight, it's mass. So just Kemp, this is just a refresher, just in case anybody knows. You might not know this, you might know this or not. Okay, so like I have this ratchet set from my shop, right? It has a weight. What is the weight? Well, this thing has a certain amount of mass, right? And its weight is how much gravity is pushing down on it, right? How much force does it exert on a scale if gravity is pushing this mass down? So you can't really measure spacecraft with weight because where the spacecraft goes, it's a microgravity environment. So weight's not a good measurement. So it's mass, right? Spacecraft are measured the way that like spacecraft efficiency is calculated is using mass, utilizing mass, because where spaceships go, there's no gravity. Well, there is gravity, but they're going fast enough to counter that gravity. You're basically falling. So you're falling around Earth, right? So with that all being said, yes, you're absolutely right, dude. It's about less mass. The rocket will go further. I mean, like, once again, it's rocket science. It gets a little more complicated than this, right? But the plain English way of how they calculate like a rocket's efficiency, like how far you can go, like with a car, right? Like take a car with an internal combustion engine or a battery, it doesn't matter. What's the range on that car, right? And how much car is there versus how much fuel is there, and how much energy does your fuel carry, and how efficiently can your engine take that fuel and turn it into work and move you somewhere, right? Pretty straightforward stuff. A car with a full tank of gas is going to have more range, right, than a car with an empty tank of gas, right? If you had a car and you took the seats out, right, except for the driver's seat, you took all the other seats out, took everything out that you didn't need, the car would be lighter. So you'd have more, your ratio of fuel to car, right, would be very different. So you'd go a lot further, right? Rockets are the same way. They're the same way. Less tiles on there is less complexity on the vehicle. It's less mass on the vehicle. In spaceflight, it's called dry mass. So anything that's on the vehicle that's not payload or fuel, right? With lower dry mass, that affords you higher wet mass. So you could carry more fuel, right? Like if you had a car and you took all the passenger seats out and you replaced them with fuel tanks, you could drive a lot further. You have more fuel in your car and less other things in your car, right? That's a really, like, I know it seems like common sense. Like, obviously, there's less tiles on the rocket. It's lighter. It's less mass, so it's going to go further, right? Yeah, that's generally the case with most physics, but with rockets, it's the margins that really matter. You need a lot of power to get up into orbit. You need a lot of what's called characteristic energy, or C3, in rocket science. You need a lot of energy to go 17,000 miles an hour. You need to propel something that fast. That's just orbit. You need to be going fast. So the less rocket you have on the rocket, the more fuel you have on your rocket, you're going to go further. I assume I didn't miss it. Says you did, but we got plenty more launches today. After the liquid fuel is spent, is the inside of the tanks clean? With Falcon 9, they replace it with helium. And yes, it's clean. So once they find the absolute minimum tiles needed, what percentage over that do you think they should use to be safe? Well, Kemp, what you're coming in on is safety margin, right? What percentage of tiles? Well, here's the thing. Rocket science is a little more complicated than that, right? It's not just how many tiles you can put on there, right? SpaceX probably has an answer to what their theoretical minimum is, right? But what SpaceX likes to do is fly the dang thing. Fly it. Figure out where your limits are with nobody on board. And if it blows up, all right. Now you know, right? In rocket science, even to this day, Kevin, this is another crazy thing. And when I explain this to people are like, huh? Right? Like, they're like, wait, what? dude, to this day, we don't have enough of a good simulation. Like our computers, math will only get you so far with doing like analysis on how a rocket's going to work. It'll only get you so far. Flight data is king. If you fly, that data is 1,000 times more valuable than just doing like a 3D computer simulation, right? Our simulation fidelity is still not the best. So like with tiles, so with how SpaceX is going about this problem, they're going to do low fidelity simulations, right? And then they'll fly the dang thing with, you know, say they took like 2,000 tiles off. They'll fly it, and if it came through reentry, okay, but the vehicle is toast, like there's holes in it all over the place because you didn't put enough tiles on it. Because the reentry heating sucks. It's like taking a flamethrower to the front of something. Like, it's not good for it. Like if they sent it through with a certain amount of times, they took 2,000 tiles off, they sent it through, and it didn't. It made it, but you're not reusing it again. But it made it. Now you have a point, real life physics, that you can use to dial in your simulation better. Because rocket science is freaking complicated. There's so many moving parts. There's so many different things going on. And dude, we can't, even SpaceX, dude, with like with Elon, with all those dang computers and all those data centers doing these simulations, rapid prototyping, et cetera, et cetera. Flight data is what you use to get to dial in your simulation and get it better. So where that safety margin is, in my opinion, I can give you kind of a plain answer, but it's intentionally vague because I don't really know. I don't have the numbers in front of me, right? The answer is how many tiles? What's the safety margin? The safety margin is enough to make it through and probably lose a couple of tiles and still make it through and have the vehicle able to not have holes in it, not be cooked. The expectation here with Starship is that you're going to reuse it, you know? If you're flying around an airplane, right, and you land the thing and the gear snaps off, I mean, you survive, right, and then you land it, your landing gear wasn't good enough, right? Or you did something wrong, or you didn't fly it right. But the computers generally don't fly Starship incorrectly. They're pretty dang good. The computers that SpaceX uses to fly these things, they're pretty good at following orders, right? So, the idea is that wherever that safety margin is, it's denoted by making sure this thing comes back and it's able to do another mission, right? But yeah, dude, great questions. Yeah, this is my bread and butter, man. You want to learn about rockets? This is what I do. Cool, thanks for answering. My pleasure, man. Those are good questions, Kemp. Less tiles means faster manufacturing as well. Yeah. That's another thing, just a little additional addendum to that thing. With SpaceX, one of their expectations for the vehicle, and when I say expectations, I mean, the plain English way of saying it is, what do you want it to do? What are you trying to get this thing to do? So SpaceX wants to they want to make it easy to manufacture. So mass production is a huge thing with this, has to be mass produced, and that's going to change how you engineer a vehicle, right? A rocket that's only designed to fly once or twice every year SLS is going to be a very different engineering. You're going to have a very different set of engineering criteria than something like Starship, right? Which is designed to fly every hour. That's the expectation. And if you want to fly every hour, you need mass production. You also need it to be reusable. So if you're thinking about it from think about like a moving assembly line. If you're thinking about it like a car or an airplane or something that's more mass producible, if the tile margin is denoted by, obviously you want it to come through reentry, you want it to be reusable, you don't want holes in it, you don't want tiles to fail, that sometimes they come off. You don't want any of that, but you also want to make it so this thing can be built quickly. And if you can if that means applying less tiles, then that's great. That improves your manufacturing process too. That's what SpaceX is thinking about. They're thinking about making a ton of these things, and that figures into the vehicle's design a lot. That's why SpaceX is using stainless steel. Most rockets, and by most I mean like all of them save for like maybe a Centaur upper stage, are made out of aluminum. They're usually made out of aircraft grade aluminum. But yeah, great questions, dude. Yeah, good stuff. Bacon, what's up? Would you be impressed if SpaceX could catch a booster between two blimps flying flying a football field sized net. They're just flexing at this point, but it would be fun to see. You know what, Bacon? I mean, that'd be kind of cool. I would be worried about, what's it called? Latent heat. So basically, even though the rocket engines aren't pointing, like if you have your two blimps with your, field goal and Super Heavy goes through the field goal, right? I would be worried about, I think it's called latent heat, but I'd have to go read more. Long story short, rocket engines put out a crazy amount of heat. They get pretty hot. I mean, I don't know if you could tell from the fire that's shooting out the bottom of this right here. A lot of the heat energy that gets put out in your reaction mass in a rocket, the heat energy, especially when you're down here, it gets convected through the atmosphere. Basically, air can absorb heat pretty good, which is why, like, some car engines are air cooled, right? That's convection, right? The heat would come through, right? The engine would come through, and honestly, the rocket engine being close to two dirigibles or a blimp, it would probably pop them because it would heat them up too much. They'd probably blow up. I mean, it'd be funny, like, as long as nobody gets hurt, that's hilarious, and it would be super cool. It'd be one hell of a flex, but yeah, I'd be worried about the heat. Yeah, Starship Hindenburging something, that'd be kind of cool. RS-25's on Space Coast and Starbase Live. Hold on.
Discovery, go at throttle up.
Hey, baby. Yeah, hey, baby. Ribbed. Nice. I also kind of dig that, Super Duty right there. Quad gab dually, F450. That's pretty good. With a gooseneck that's towing a rocket engine. Yeah, I don't hate that. I don't hate what's going on right here. Also, cool tugboat. Yeah, you guys want to realize how big a shuttle engine is. Hey, Krishel. 59 kroner. Thanks. Hey, you're very welcome. Thank you for the super chat. Appreciate you. Why are they towing shuttle engines through a field? That's the press site, guys. This engine is probably set up to be able to be shown off for the Artemis 2 mission. Yep, that's the KSC press site. I know because NSF cameras are super close. They're also flat. What the hell? Should we tell them about that? Give me 1 second. I just got to get a timestamp on that. Hold on. They say that's NASA's feed doing that. Typical. Maddie, it's been going on with NASA's cameras. Yeah, okay. Yeah, that's what it's just telling me. Yeah. Oh, yeah. That is a big, that's what I mean, guys. Look at how big that motor is. You think you know the size of a shuttle motor, and then you get a shot like this, and you're like, that is actually quite large. You could... Oh, that's D. Is that D and Max? I think that's D and Max. Oh, no, that's not Max. Hang on. That's Brendan Burkoff. I know that dude. That dude's cool. Hey, what's happening here? Well, we just watched the Starlink mission, and then on NSF, on NASA Spaceflight, on Space Coast Live, it looks like they brought in a shuttle engine to the press site. There's Max. I told him to get one on the other side so we can see the serial number, and that's really weird that he actually just walked right over there. I said, that's what I just typed. I'm like, Max, go to the other side. Get the serial number. That's so weird, dude. I'm sorry. That makes me laugh. That is an RS-25. That one... let's see. That's a Block 2 SSME. That's why I asked Max what the serial number is. That's a space shuttle engine. They have it labeled as an RS-25 engine, but that one, I mean, it's real. That's a real one. It flew on the so there's serial numbers on the the low pressure oxidizer turbo pumps. See where those red caps are? That's the LPTOT and the LPTHPT, or low pressure oxidizer turbo pump and low pressure hydrogen turbo pump. I told Max to take a picture of the other side because the serial number you could figure out. So like it's the VIN in my winter car. The rocket engines have stuff like that. They have stuff like VIN numbers and serial numbers on the components that'll tell you when it was made, where it was made, what's the sequence number on it. Yeah, you can figure out all that stuff it's like tracing the VIN in summer car. It's the same thing, dude. You could do that with rockets. You could do that with airplanes. You do that anything that's in serial production. You can usually figure that out. He says it's in work. Brother, that thing is beautiful. Look at that engine. Tell Max to put the coat on his head for safety. I don't think we should do that. Is it like airplanes where every part has a number? Yes. That's the other reason why rocket engines are so damn expensive, Flykin. Every component gets serialized. Every single thing. With rockets, because if something goes wrong, it's often hard to tell what goes wrong. It's often hard to, you can't tell what goes wrong unless you have good serialization. Meaning that if a bolt fails, right? If a bolt doesn't work, you need to know when that bolt was installed, where that bolt came from, where it was manufactured, when it was manufactured, how it was transported, everything. Everything gets documented with rockets. It has to be airtight like that, or else if something does go wrong, you could potentially screw up a fault tree analysis. So everything is serialized, more than airplanes, dude. Who made it, who inspected it. Yeah, even down to who put the bolt in, what torque wrench did you use? Was that torque wrench calibrated correctly? Who calibrated the torque wrench? Where did the torque wrench come from? Who'd you buy it from? Where was it made? When was it made? Dude, the supply chains are documented that hard. Because these things, when they blow up, there's usually nothing left, right? There's nothing left that's worth looking at if something goes wrong. So having this also reinforces quality assurance, right? Like, if you know where every bolt came from, and you know where every bolt was installed, and you know who installed it with what torque wrench, and you know that torque wrench was good, you know that part's not going to fail. Did someone say torque wrench? Hey, Rob, how good are your torque wrenches? Yeah, that's a question. I know you're going to say good. Wait, where's Max and D? They're there. Yeah, Dan, exactly. There's a paper trail and everything. There's even a paper trail for the paper trail. This is what makes it so damn safe, dude. Yeah, just you got to cover all your bases with rockets like that, dude. NASA already uses them. Really? Do they routinely twist for maximum allowance? The torque wrench was calibrated by the Department of Bureau Weights and Standards, and it's the type that technicians used and NASA engineers. It's engineered to be dead on balls accurate. Dead on balls accurate? Yeah, it's an industry term. What engine is it? That's a shuttle engine. Actually, it's an RS-25, but yeah. Sorry for the unrelated question, but why does the Starlink stream end shortly after T plus 8 minutes? Yugi, the truth is that SpaceX launches so many of these things, they don't want to put in all that extra production for... They don't want to put in all that extra production time for Starlink. The Starlink satellites usually deploy about an hour after liftoff. That's a lot of extra stream time that SpaceX just doesn't want to do. They're not us. You know, they're not NSF. They're not me. What's a Ute? Too what? Artemis 2 made the cover of Time magazine. I saw that, Psycho. Yeah, man. What's the difference between a Block 2 SSME and SLS motors? T-Man, a Block 2 SSME, they changed the name with the SLS program. A Block 2 SSME is now an RS-25D. It's basically the same engine.
Discovery.
It's basically the same thing, barring a couple of things here and there. Yeah, for the first, I think 3 SLS launches, they are basically just using up all the old shuttle hardware. That includes SRBs, rocket engines, like RS-25s. That, yeah, they're just... Hey, London, 12-month resub. Thank you. All torque wrenches also come standard with the torque angle etched into the head. Really? That point when you realize SLS Block 1B should be SLS 1. Yep. What's the engine weight? You want to hear something crazy? That engine weighs more than the truck, but not much more than the truck. RS-25s, for their size, dudes, are ridiculously light. They are an insanely lightweight engine for its size. It's a big motor. I mean, look, it's huge. I think, I do believe RS-25s are 5 tons, so 5,000 kilos. So that's, like I said, little over 10,000. I think that's actually like 11,000 pounds. Like I said, it doesn't weigh as much as that truck, or no, the truck. Well, I mean, that's an F450 with a utility bed on it. So actually, yeah, I think the truck weighs more than the motor. That would be my guess. Chamber and turbine housings, yeah, it's all the same. RS-25D and Block 2 SSMEs. Like I said, RS-25Ds are just the name of the engines, the X-Shuttle engines. They don't want to call them Space Shuttle main engines, right? It's an optics thing. They don't want to call them SSMEs because that reminds people of the Space Shuttle. So they changed the name. They're basically just shuttle engines, off the shelf. NASA doing show and tell today? Something like that. Give me 1 second, dudes. Oh, I see it, SVL. Yeah. Oh God, what did I walk into? Nothing, just rocket engines. Hello, baby. I also really dig that Ford with the NASA livery and the moon painted on the quad cab. Excuse me. How does the RS-25 compare to Raptor and Raptor Vacuum? So the RS-25, Maddie, is basically... The RS-25 is pretty dang comparable. That motor makes about 2,400 kilonewtons of thrust at 452 seconds specific impulse. Raptor makes about the same power, 2,400 kilonewtons. I mean, it's probably going to go higher than that because Raptor 3, 300 bar chamber pressure. But Raptor makes around 380 seconds specific impulse. So it's... dude, like, this is... SpaceX fanboys aren't going to like me saying this. The RS-25 is still better. It's still a better motor. Raptor... Now, what Raptor has going for it is its power to weight.
Oh, this is space. I'm in space.
There's a lot less Raptor 3 than there is RS-25. So even if they didn't change the thrust output on the engine, the Raptor 3 making 2,400 kilonewtons of thrust, Raptor is in such a smaller package than this, you can cluster them together. Now, don't get me wrong, you can cluster together RS-25s as well. They are a regeneratively cooled engine. They have copper cooling channels in the nozzle. Basically, these low-pressure pumps, the reason why these have low-pressure pumps and high-pressure pumps, so, east and west are low-pressure pumps, and then north and south are high pressures.
I'm in space.
Foxhot, thanks for the gift and sub. And Thomas, thank you for the gift and sub, guys. And then Sun Temple, thank you for the 500 bits. The reason why they have pumps left, right, like low pressure pumps and then high pressure pumps is because some of the liquid hydrogen, because this is a fuel rich stage combustion. Well, not, I mean, all of it goes through the nozzle and it heats up the hydrogen. It stages it. That's your staging. And then from there, it goes into an accumulator, which is down here somewhere. And the accumulator is working like a buffer for the injector. That's the really, really, really simplified explanation of how that all works. So these can operate in close proximity to each other. Raptor is a regeneratively cooled engine too, and it does the same thing with methane. It pumps the methane through the nozzle. It keeps the nozzle cool and it turns the methane into gas to make it easier to get atomization. So you get more efficiency that way. But Raptor will never, ever be able to get the efficiency of an RS-25. You're not going to see a Raptor making 450 second specific impulse. Just because of the limitations of methane. Now, that's a double-edged sword here, though. That...
Oh, this is space. I'm in space.
Bio-gifted 27 subs? Thank you, I think? Thanks, man. 27, that's in a row? Had to round out your total. Oh, thanks, man. Now, with the RS-25, right, it's always going to be more efficient because it's using hydrogen, but that's a double-edged sword. And Bio, thank you very much. I appreciate it. It's a double-edged sword. The double-edged sword is that hydrogen, there's an allure of hydrogen to use it because it's so ridiculous. It's like, okay, so for the people that don't know a lot about rockets, 380 seconds specific...
Oh, this is
Fluffy
space.
gifted
I'm in
5.
space.
Oh, jeez. Nice. Fluffy gifted 5 subs. Right? I appreciate that. Thank you. You guys are scrambling my brain. I'm trying to tell you about efficiency numbers here. So, you're never going to be able to hit, where was I? Okay. With Raptors are never going to get above 380, 390 seconds specific impulse. they're never going to be able to hit the 452 second specific impulse that is. Now, just a little bit on specific impulse. What is that? It's basically the miles per gallon, the MPG, for the rocket engine. It's measured in burn time seconds. So it's basically how efficiently does it take a certain quantity of fuel and blow it out the back. That's the really plain English way of saying it. You have a certain quantity of fuel. How efficiently can you take that certain quantity of fuel, blow it up, and shoot it out the back at high speed? Right? The higher the speed you shoot it out the back, the better. Right? The better the jet is on a rocket, the faster the jet is on a rocket, the further you're going to go. So it's measured in burn time seconds. It's akin to miles per gallon, guys. So 452 seconds specific impulse, guys, is like 100 miles to the gallon. Now, Raptor, with its 380 second specific impulse, is like 60 miles to the gallon. But for that, like, almost twofold increase, well, not twofold, probably like a 30% increase in efficiency with a hydrogen motor, hydrogen is really difficult to work with. That's the problem. That's why SpaceX is using methane. Methane is a little bit less temperamental than hydrogen is. And that's why SpaceX uses methane. It's easier to move it around. Hydrogen is tough to move around because hydrogen, when it exists as a liquid, it's so ridiculously small. And because the reason why hydrogen is temperamental is because the window in which hydrogen exists as a liquid, so we're talking about phases here, phases of matter, right? The window in temperature and pressure wise that hydrogen exists as a liquid is very, very narrow, just because of the structure of a hydrogen atom. It's very, 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 very small. So, for instance, I'll give you an example. Water. Where does water exist as a liquid? Water exists as a liquid between 0 Celsius and 100 Celsius. Below 0, water solidifies. Okay? Above 100, it boils. It turns to gas. Right? So you got 100-degree nominal range in which water exists as a liquid. With hydrogen, that nominal range is probably like less than 4 degrees C. Like, you have a slight variation in the temperature for hydrogen, it'll turn to gas. And on top of that, guys, binary.
I'm in space.
Gifted 5, thank you. Hey, Carson, what's up, man? 7-month resub, I appreciate you. And it's NASA Ford tough, that's right. As Alex put it, hydrogen is an escape artist. That's a good way to say that. So on top of hydrogen having a very narrow window for existing as a liquid, that narrow window is basically all the way almost to the point of absolute zero. So absolute zero is basically nothing. Like absolute zero is vacuum, right? That's the absence of heat, right? That's the absence of anything, right? No matter inherently carries no heat energy, right? Because electrons. If we're gonna get into chemistry, right? So, and once again, I'm not a chemist. If I didn't say this exactly right, let me know. So hydrogen exists as a liquid very close to absolute zero. So if that temperature gets any lower, let's be real, it won't get any lower. Hydrogen could potentially solidify, but it most likely won't. But that leaves basically an infinite level of hotness before hydrogen turns to gas. Basically, like Alex said, hydrogen is an escape artist. Hydrogen wants to exist as a gas, and it really doesn't care what you think about it. I want to be a gas. No, you don't. Yes, I do. No, you don't. Yes, I do. That's what SLS is constantly fighting. When, like, we saw it during Artemis 1. Artemis 1, with all the wet dress rehearsals that they did, with all the tanking tests that they did, they had problems with hydrogen leaks. Because when you're using a rocket with liquid hydrogen, you have to take into account that it's going to leak. You will never prevent it. You'll never prevent it completely. So basically, think about, like, if you're a plane nerd, an SR-71, the SR-71 tanks are designed to leak a little bit when it was taking off, and they seal up when it's working, like up at high altitudes. They'll seal up, they won't leak. There are tolerances built into the rocket, because the rocket with hydrogen, it's going to leak. You really don't have any choice. So it's basically, you have to deal with the leak. And how they deal with it is a purge flame. So somewhere on 39B, there's a flame. There's a torch. I think that's it right there on the left, but I'm guessing. I forget where it is. I studied too many launch pads. So you got to give hydrogen a place to burn off. You got to give it a pilot light like a gas stove. Same idea. So it's gonna leak. So you're gonna get a lot of benefits from using hydrogen with a rocket engine, guys, but that doesn't come without stipulations because physics hates us. That's the short answer. That little end part at the end is the short answer. So, how is it? Is a Raptor engine comparable to an RS-25? Yeah, they make a similar amount of thrust. Raptor will never be as efficient, and on paper that looks like it's a worse rocket engine. But Raptor using methane is a choice. SpaceX is opting for something just a little bit less efficient than the most efficient thing on the table. But they're trading efficiency for reliability with that. So they are kind of comparable, but they kind of aren't, but they kind of are. What's crazy to me, Maddie, the craziest thing about this to me, dudes, is that we are comparing an engine that was really kind of built in the mid-70s. The RS-25 design kind of came about in like 1975, 1976, somewhere around there. And the fact that we're still comparing it to modern rocket engines that are built today is a testament to how far ahead of its time that thing actually is. That thing was the Raptor engine of its time. It is insane for what it is. It's actually ridiculous what that thing does. Also construction techniques. Yeah, sure. Yeah. The fact that you can operate so well at sea level and above atmosphere is just mint. Yeah, that's the other thing to take into account. So a regular Raptor engine, like a regular Raptor 3, has a nozzle that's optimized to work down here. A vacuum Raptor engine, or Vactor is what I like to call them, is designed to really work better up there, right? The shuttle engine has a nozzle design that was so far ahead of its time, it can work down here and up there. It doesn't really care. How they did that, if you really want to know, this is just some trivia, and I know we're still technically badged under Starlink, but the RS-25's nozzle has a slight impingement at the end. And the slight impingement, along with what's called the expansion ratio of the engine, causes a gas impingement. Like if you really sit here and look at an RS-25 nozzle, there's a picture of it firing on a test stand at Stennis. The nozzle goes out and then it actually kind of curves back in a little bit. See? It curves in on itself at the end of the nozzle. Dude, that nozzle architecture is still cutting edge to this day. They put an impingement on it to try to make the engine not so. They put an impingement on it to not have flow separation, or you don't. With a rocket engine, you don't. We're talking aerodynamics now. With a rocket engine, you do not want drag inside of the nozzle. That is really bad for it. That'll break it. If it has, if you get drag in there, what's called flow separation. If you get a flow separation due to an overexpansion, overexpanded nozzle, it'll explode. The thing will blow up. That flow separation in the nozzle to a rocket engine is like no oil to a car engine. It'll blow up. Yeah, you'll visit Rodney, and with rocket engines, visiting Rodney means you're not finding any piece of the engine because it exploded. Hey, Bradley, 65-month resub. So that nozzle design, having that slight impingement and basically the shape of the nozzle, makes it good to fire down here at sea level and good to fire up in space. Dude, that is still cutting edge. I don't care what anybody says. People could say SLS is based off 1970s tech, blah, blah. Dude, that's still, no one's been able to do something like that since. Now, SpaceX can do it, but not because they're impinging gas in the nozzle. A Raptor 3 and a vacuum Raptor can fire down here. SpaceX overcame that problem not necessarily with optimized nozzle architecture. SpaceX overcame that problem with basically doing, I'll talk cars again for a second. If you guys have ever seen the Fast and Furious movies, they have those buttons on the steering wheel and they press it and it's the nitrous, and you get nitrous injection into your car, right? And the thing goes faster. SpaceX basically overcame that nozzle architecture problem with their engines by basically making it, when Raptor fires, the button is basically held down, you know? Now, SpaceX doesn't use nitrous oxide in their rocket engines. They use liquid oxygen, which is better than nitrous oxide. Nitrous oxide is N2O, 2 parts nitrogen, 1 parts oxygen. So it's 33% oxidizer. Liquid oxygen is 100% oxidizer. it makes things blow up real good. But Raptor is basically on overdrive the whole freaking time it fires. How SpaceX was able to do that is, so the Raptor engine uses a full flow stage combustion, meaning that the plain English way of saying it is that they have 2 jet engines on top of the rocket engine. One is for fuel and one's for oxidizer. So this jet engine over here burns with a little bit of oxidizer and a lot of fuel, and this one over here burns with a little bit of a lot of oxidizer and a little bit of fuel. The idea is that they're trying to get the oxygen spread out, and they're trying to get your methane spread out as much as you can. They're trying to spread them out, because the reason why you spread out, the reason why they want them to turn to gas, is you're going to get what's called better atomization. So better atomization will give you a more efficient burn. In rockets, in cars, it doesn't matter. Jet engines, Smarter Every Day, if you guys know Destin, has a video about carburetors that show atomization. I don't know if you guys have ever seen that Smarter Every Day, where he made the acrylic carburetor and you can see the fuel spreading out before it goes into the motor because it hits it at low pressure. And the fuel spreads out and it basically turns to vapors, right? That's atomization. You want that with a rocket engine. The problem is, right, with a rocket engine, you need low pressure to get atomization, right? And inside of a rocket engine is anything but, right? So that's one of those problems to solve, right? It's part of the reason why this is so complicated, right? So what SpaceX does is they figured out a way to take the methane, put it in a methane jet engine that's running really, 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 really heavily favored for fuel, way more fuel than oxidizer, and that gets the methane to spread out. And then they have an oxidizer power, a liquid oxygen jet engine that has a little bit of fuel and a lot of oxidizer, and that gets the oxidizer to spread out. And then they shoot the exhausts from those jet engines at each other. And that gets the gaseous methane and the gaseous oxygen to combine. It gets them to atomize, and then they throw that into the combustion chamber and blow it up. That creates an extremely efficient, extremely high pressure burn. So in rocket science, it's called really high chamber pressure. Really high chamber pressure means you're shooting an insane amount of gas out of the nozzle, and nozzle architecture doesn't really matter at that point. If you're making 300 atmosphere pressure inside of a rocket engine, it doesn't matter what the nozzle looks like. So SpaceX overcame that problem by just, well, making it more powerful. Let's make a rocket engine with a similar nozzle. They don't need an impingement. Let's make it. Let's just make it with the proverbial nitrous button turned on all the time. Why not? Sure, that's fine. Cool. That's what Raptor is. So like comparable to Raptor to RS-25, they compare and they solve the same problems for different reasons. It's different reasoning. Now the big reason why, like SpaceX overcame this problem with more thrust, and why the shuttle engineers overcame it with kind of a nozzle impingement. The reason why they did that is, well, basically, with the shuttle program, you weren't making as many engines, right? The space shuttle has 3 RS-25s. It had 3 of those. SLS has 4 of those. You know, I mean, the space shuttle is the primary driver of that thing's design, right? You're not going to make a lot of these things, right? So it's an easier problem to solve just to have the nozzle, have that impingement at the nozzle like I was telling you guys about. That's an easier problem to solve than trying to increase the chamber pressure to overcome flow separation in an overexpanded nozzle. right? Easier problem to solve because you're not making as many engines. SpaceX, on the other hand, cranks Raptor engines out like candy, right? They crank them out like candy. And when you're making a ton of these things, it makes it worthwhile to solve that high chamber pressure problem. And that's why Raptor is so ridiculously good. Because that becomes an easier problem to solve if you're making thousands of engines and not tens of engines, right? Yeah, dude. I'm staring at her butt. I'm not gonna lie to you. I'm staring at her butt. I'm sorry, I just can't help it. Like, tugboats are cool. I like that. There's 4 of those on this thing, but I can't see up their butt. I'm staring up her butt, and yeah, I'm a pig for doing it. I don't care. Look at that thing. That's pretty nice. That's very nice. So load is no longer a red zone. Can we park there? Yeah, it's for loading and unloading only. What is this? I am stupid. What does that mean? I mean, you're right. I am stupid. No, I know that's not what you meant, Marcon. So, Marcon, I'm just going to get right down to brass tacks because this isn't a space news segment, and frankly, we got some winter car to play. I want to drive that car around. I even have the racing rig all set up again today. The short answer here is that so SpaceX wants to do an IPO, an initial public offering. We've heard them talk about wanting to do that. The reason why they want to do an IPO is because Elon and company think that, and he's probably right. I don't know. Like he might be wrong. I don't know. He thinks that having a Starlink, an extra shell of Starlink satellites up on orbit with AI laced into them to create literal cloud storage in the clouds, so to speak. It's in space, it's not in the clouds. Is going to be the correct move to fund a Mars colony. Yeah, that's the plan. At least that's the plan to my understanding. If you make a Starlink satellite and you offer on-orbit data services, you can basically access a data center anywhere in the world. You could be at the South Pole and you'll have the same latency getting to data services as you would in New York City. That's the idea. This is completely separate from Starlink. Starlink is just internet connectivity. This is internet connectivity and web services on top of that. So like hosting websites on satellites floating around in space. So what SpaceX is doing, what that article is about, or what that thing from Joey Roulette is about, is the possibility of Elon merging SpaceX with his AI company, X.AI, in anticipation of an IPO. The reason why they're going to, the reason why they want to IPO SpaceX is because Elon wants the capital to be able to build a AI-assisted Starlink data center swarm in space. And they need additional funding to do it. And if it pays off, it could potentially fund Starship basically indefinitely, to the point where we have a city on Mars. That's the idea. Now, that doesn't sound like a bad idea. If it's one thing that I've learned from covering Elon Musk and kind of all of his decisions over the years is it's not wise to bet against him. He will, even if odds aren't in his favor, he will persistently drive into the ground until he gets what he's trying to do.
Discovery, go and throttle up.
The guy is the most persistent son of a gun I've ever seen, ever. Like, entrepreneur doesn't even put, like, I wouldn't even call him that. The guy's ridiculous, right? And I'm not trying to glaze him either, guys. Like, I don't like saying this, and I'm not trying to be a jerk. I'm not trying to concern troll SpaceX or anything like that. I am worried that hitching SpaceX's wagon to the potential AI bubble could be catastrophically bad for our space flight ambitions in the future. That's why people don't like this, Marcon. I'm not a huge AI tech bro, dudes. You guys know I like carburetors. Like, we rebuild carburetors in the garage, and I clean them, and we fix snowblowers and stuff. Like, I'm not that big of a tech bro, to be 100% honest with you. I understand the potential gains from having an AI-backed data center on orbit. If that play works, trillionaire would not be what you would call Elon. No. Trillionaire would not be what you call it. He'd be a quadrillionaire if that works correctly. There is so many applications for tech that just even like past AI, right? Like, it's not just about, having a data center on orbit and web services on orbit, right? This could potentially, like, okay, I'll give you just an example. And don't get me wrong, they've never said that they were going to do any of this at all, right? But just a conditional hypothetical, if you will. Having a data center on orbit, right? And then having Starlink and this data center architecture is pursuing a direct-to-cell style of data communication, meaning your cell phone doesn't need a Starlink antenna to communicate with Starlink satellites. You can basically call, and the Starlinks are cell phone towers. If you're getting that kind of connectivity, right, the possibilities here are endless. The reason why the possibilities here are endless is because that could bolster, like, full self-driving for Tesla. Tesla will have connectivity back to Tesla's, AI hive mind of, road simulations, and literally Tesla could just map every road in the world. You think the Google Maps guys driving around with the cameras are going to get you a good street view? Tesla, you could theoretically build an exact 3D database of every single road in the world with that kind of connectivity. And that could be super useful to make full self-driving better. Elon will follow through with his, visible light camera, and he'll kill the whole thing. The guy hates LiDAR for what it's worth. He doesn't think LiDAR is the way for full self-driving. He thinks because the roads were designed around somebody seeing stuff in the visible light spectrum, that the car should be able to do that too. But think about this, guys. This paves the way for Optimus as well. Optimus could have connectivity anywhere in the world. Like, you could have a bunch of Optimus robots working out on an oil rig, for instance. Now, don't get me wrong. I'm not saying that that's going to happen. That was just a hypothetical. You could have the point that I'm trying to illustrate is that you could potentially have robots like tending a farm. Optimus could run a farm, and he could run a farm remotely. Farmer would sit in his house and just control the robots all day with that kind of connectivity, right? And the farmer a farmer wouldn't even need to have his house on a homestead. He could live in the city and just control the robots from an office, right? Like, the possibilities here are kind of endless. You could, with the Optimus, the point I'm trying to illustrate is that Optimus could do remote work for humans that you would never, ever, and you have connectivity anywhere, right? Between cell towers, the Starlink satellites, you could have connectivity anywhere, and basically Optimus will end up like Pluribus, if anybody's watched that show. Basically, quote unquote, infinitely helpful. So the applications here and the IPO, it's a bet for sure, and I understand the benefits, but also, as a spaceflight fan, I really don't like how spaceflight is getting basically absorbed into the AI bubble. And if the AI bubble pops, that could be extraordinarily volatile for our future spaceflight endeavors. some more corporate farms, something like. I mean, guys, that was just a hypothetical. I'm not a tech bro. That's my understanding of it. I think I get the play. I think I understand what he's doing. I just think that's if the AI is volatile. It's a volatile market. Like right now, people are we're basically racing against time before we run out of resources and manufacturing capability to scale to create artificial general intelligence. When they get to the point where you can't manufacture enough to be able to scale the AI architecture to get to a point where you have like a data center that's self-aware, for instance, yeah, well, you see RAM prices spiking. RAM prices are spiking like crazy because of this, and you will hit a theoretical wall at some point. And if that happens before they figure it out, we're gonna hit basically a technological dead end, and that could be bad for hitching SpaceX's wagon to something like that. Storage is spiking too. Exactly. We're gonna get to, if you don't solve it, we're basically. Okay, let me give you an example. During the Cold War, part of what ended the Cold War and part of what made the Soviet Union fold was the arms race. The Soviet Union could not afford to keep up with how much bombers, missiles, guns, ammunition that the U.S. was making, right? They weren't able to keep up. They weren't able to keep up their defense spending due to the limitations of their planned economy, right? We basically drove them into the ground financially, and then Chernobyl happened on top of that, and then that caused, them basically they're over budgeting their defense to try and keep up with the United States in the 80s, basically hampered the rest of the entire system, and now people don't have enough to eat, and it folded the entire country, right? It dissolved, right? Because it was untenable, right? Now, how that applies to, this AI bubble is that there is no guarantee that outspending someone on AI is going to get you a victory here. With the United States and the Soviet Union in the 80s, that was pretty surefire. I mean, the Reagan administration pretty much knew what they were doing, I'd say. I mean, some people, I don't know. That's not an endorsement or anything. That was the right idea. Bolstering up capitalist countries, South Korea, Japan, Taiwan. They tried to do it with Iran and it failed. That didn't work. West Germany, for instance, the entirety of Western Europe, you bolster that, you make them capitalistic enclaves, and all that combines to drive it into the ground, right? There's no guarantee that that's going to happen. There's no guarantee. Like, there's no technological limitations at X.AI or OpenAI. They're basically just duking it out in a slugfest, right? To the point where they're just buying up. They aren't even buying up RAM or hard drives at this point. They're buying up the raw materials to make this stuff. You're basically the AI bubble is basically an arms race to see who could get artificial general intelligence, who can make a fully self-aware computer. It's basically an arms race to do that. And there's no, in my opinion, there's no guarantee that it's going to happen. Yeah, I know, Katra. It's bananas, right? Don't forget the Berlin airlift where we landed a plane like every 20 seconds. Well, yeah, exactly. The idea was to show that our system is superior to theirs. And I don't want to get into a conversation about communism versus capitalism. It's just an example. With this example, how it pertains is that we don't know where the end is. So if you're going to get to a point where you just keep going and 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 keep going, that you're gonna. It's to a point where we might not be able to manufacture this stuff fast enough, right? And you're pointing all this money into the this arms race of artificial general intelligence, right? And you're putting all this money into it, and you're not gonna get any return, and because what's gonna happen, you either scale the industries and scale the raw materials and scale the mining and build out an industrial base to be able to support this kind of production, which no company is going to do, right? Because the company isn't going to take a risk on expanding their manufacturing capabilities just for a bubble, right? They don't know. You could build out twice the amount of silicon wafer production at your factory, in your silicon wafer factory, and then they could figure it out, and now you have two factories that don't do anything, right? You know, you're never going to meet those production. No one wants to scale to that production. So there's kind of an impingement point here where the arms race to get AI and our manufacturing capability to keep up with it are going to cross. And people, that's where I think the AI bubble will pop. And once again, I don't think it's wise hitching SpaceX to that wagon, because if it pops, SpaceX could potentially go down the drain with it. Nah, King, I'm always for reindustrialization. Please build more factories. I think the same should be said for you guys. I'm wondering if they're just throwing raw processing power on a pile hoping for an emergence. That's what I'm talking about, Ando. That's basically it. There's no end goal here. The end goal is AGI, but we don't even... Can we even just... What is AGI? What does that mean? Right? What does that mean? What does it mean? Double rainbow. What does it mean? Well, what's AGI? Like, nobody can even agree on what Skynet would look like if we do get it. There's no clear goal here. We are just spending into a disaster, like hoping we get something useful out of it. I don't personally, I understand the play. I think it's potentially return on investment here could be billions, right? I don't think risking because SpaceX is such a major stakeholder in NASA at this point. NASA entirely depends on SpaceX to get people to the ISS. They're entirely depending on NASA to get people to the surface of the moon. I don't think hitching SpaceX to the AI bubble into an infinite spending loop is the wisest decision around. It's a gamble for sure. And we know Elon, he goes all in on stuff like this when he decides he wants to. That's how he rolls. He might be right. What am I to say? He knows a lot more about this than I do, you know? Yeah, Fluffy, it's only just like this. That's why I use the Soviet Union as an example. The Soviet Union ended up to the point they spent so much on defense that they couldn't feed people. Look what happened. See what I mean? I don't think hitching your space program to an ideology like that, not a communist ideology, but this ideology that we can spend our way into AGI is a wise decision. That's just my personal opinion. People are going to disagree with me on that. My opinion is not infallible. I am not a tech bro. That's just an outside observer. Yeah, even Blue Origin's doing it with their tread wave or whatever. Like, it's untenable. But at least Blue is just doing a data center. As far as I can tell, Blue's TerraWave is not AI backed like this is. I don't know. That's just my personal opinion. I'm not trying to be down in the dumps about anything. Look, I can see the positives here. If Elon and SpaceX, if he merges XAI and SpaceX into one endeavor and then IPOs and gets the money that he needs to outspend everybody and solves that AGI problem while building out an internet satellite data center constellation, SpaceX's Mars ambitions gets funded completely. Like, that is a city on Mars. That is enough capital to city on Mars and not have to worry about a return on investment for decades, centuries. Like, I see the play. And I'm not one to bet against Elon Musk. I don't do that. Every time someone does, he'll never do that. Like, I mean, don't get me wrong. He ain't perfect. Like, he's had some screw ups and he overpromises a lot, but he's, the guy's a salesman. What do you want? But if that play works, Dude, we're retiring in freaking we're retiring in the Mariner Valley. If that works. We could go to a retirement home on the Mariner Valley, in the Mariner Valley on Mars. Total Recall style, minus Cohagen. I don't know. Just my theory, guys. I know people are going to disagree with me. I know people, are going to agree or not. This is not me so much reporting the news, but me just kind of telling you guys what I think. See you at the party, Richter! No, you wanted to be Quaid! 2 weeks! 2 weeks! Yes, yes. Thank you. I knew I could make a Total Recall reference and you guys would get it. I knew it. Man, I got 5 kids to feed. Maybe wrong, but at least they're not doing all that circular guarantees like OpenAI, Oracle, and NVIDIA, unless I missed it. I don't know. Moist, I stopped. I gave up on trying to keep up with the AI, and what's going on with that a long time ago. The information comes at you so hot and heavy that I wouldn't have the bandwidth to do it. I stick to spaceflight stuff. That's my wheelhouse. It's so much. There's so much. The news cycle is ridiculous every single freaking day. Don't forget about Johnny Cab. Yeah, which freaking Tesla is making, which is... All right. Actually, if some Tesla bros could shed some light on why Tesla is stopping making the Model S and the Model X, I would really like some insight into that. I heard that was happening, and I'll admit I didn't really... I guess I kind of understand the decision, but also... The production will be converted to Optimus. They don't sell enough. Let me take a look. Oh. I mean, keep in mind, I understand we just had that conversation about AI, etc., etc. But the AI overview is saying that in 2022, a high point, they sold 90,000 Model S's. 2023, they sold 26,000. 2024, they sold 15. 2025, combined sales between the Model S and X is 30 to 50,000. Oh. Yeah, okay. Yeah, that's, that pretty much, yeah. Guys, I don't know a lot about Tesla. I'm not the biggest Tesla bro around. I do know about car production. Car mass production is one of my hobbies because I'm a loser. Like, I'm a weird dude. Like, I don't know what to tell you. 26,000 off the production line is no good. That is not even enough to break even on the production. Good car sales. So like, if you want to know a good selling car, 50,000 a year is pretty good. If you sell 50,000 of the car that you paid to mass produce, that pretty much breaks even. If you sell 100,000, you got a winner. If you can get cars into 6-figure production annually, it doesn't matter the car, Tesla, Ford, whatever. That is a cash cow. 26,000? No. Not good enough. That's, they sold in 2024, they sold 15,900 Model S and 21,000 Model X. It's not good enough. That's not tenable. It's not tenable for your assembly line. That literally makes, that assembly line is operating at a loss, producing 15,000 cars. That's a loss. That's a big loss. Can you trust that AI overview? I would assume it's pulling from the Tesla sales reports. Here, let's look at a website, an actual website. This is Trident's. I don't know Trident's, but Yeah, see, these numbers are good. You're selling 1 million cars annually. That's 1.6 million cars annually. That's great. That's like better than Toyota. And Toyota's kind of the gold standard for that. Get off the screen. Do we have anything about production numbers? All right. Tesla annual production from 2018 to 2025. Yeah, see, this is good stuff. That is why Tesla's stock spiked. Look, because they figured out how to mass produce to fill the demand. Look at that. 1.8 million cars, 35% growth. 1.3 million, 47% growth year over year. That's disgusting. That's really, really good for a new player. Like, look at that. That's why Tesla's stock spiked, because they figured out a way to really mass produce automobiles. I want to see. Okay. Yeah, look. Okay. So that's 3 and Y sales. This is other models here. Look at that. So we sell 1 million trucks a year. That's just trucks. Yep. Yeah. So look at the fall off here. 66, 57, 24. I would attribute that to the pandemic. 66, 68. These numbers are tenable. That's fine. You're dipping below 50,000 for 2 assembly lines between the Model S and the Model X. Dipping below 50 Gs, which is in line with that AI overview. That's, yeah, it's not, I can tell you from an automotive manufacturing standpoint, that's not tenable. It's not tenable. You know, either find a way to refresh the Model S to sell more of them, or just close that chapter. And they chose Elon's pragmatic, and you know, he's pragmatic like that. Just get rid of it, do something different. Geeson's here, okay? Yeah, okay. That's the reason. That's the big one. They're just not selling enough of them, dude. Aren't the S, the X, and the truck lumped together? If Cybertruck is in there, zeros, then yeah, that's probably not great for Cybertruck. But also at the same time, I really, truly, and honestly believe that Cybertruck is a concept car that they put into production. The real thing about Cybertruck isn't about Tesla building a truck. It's about pioneering. They used it as a test bed and a pioneer to kind of map out 48-volt architecture in cars. That was the reason. And the reason why is that 48-volt electrical architecture in a car is it's such an avant-garde thing. It's about as avant-garde as the design. Like it's as radical a design as the outside of Cybertruck is, and that is what they were going for. That's why Cybertruck looks ridiculous, because they wanted a truck that looks ridiculous that matches the underlying electrical architecture that goes with it. A 48-volt architecture is unheard of in an automobile. Most automobiles are 12-volt, like the one in Winter Car. That 76 Ford Taunus is a 12-volt architecture. Most cars are 12-volt. But because a lot of cars nowadays have more electrical, they have more electrical components on it, satellite navigation, you have infotainment, you have all these sensors, all this stuff that needs all this electricity. You know, it's getting to the point where modern cars have DC to DC converters left and right, and the overlying architecture is all 12 volt, but it's 12 volts to a DC to DC converter to run that electrical component, and then you have another DC to DC converter that's running the infotainment, et cetera, et cetera. It's just a kit bash of different voltage architectures and they have to put all these DC to DC converters in a car nowadays to run all this stuff. And that's Cybertruck bucks that trend. Yeah, Papa Bear, I did. Did I miss the launch? Yeah, Jet Route. The launch was a little while ago. We're just discussing tech right here. In fact, guys, I think I'm going to switch over to Winter Car. This kind of ended up becoming a space news. So I'm going to retitle it over on YouTube. The Semi is also on that list. Well, semi-trucks aren't made in the same production as light-duty vehicles, right? So if you're only producing 20,000 semis a year, that's fine. Trouble is, huge investment in Texas Gigafactory for it. That was a gamble. They need the factory to be at capacity, probably building something else. They're gonna move into mass producing Optimus, Bob. Once again, think about that play that I told you. Full self-driving, connected to a hive mind that you can rapidly prototype and it's learning every 2 seconds. And then think about think about Optimus like how you'd think about Amazon Alexa, right? Sorry if I set yours off. Right? Did you see Mr. Beast in Starbase? I did, Ator. Yeah. I have not checked the Mura 5 update yet, but it looks good. It looks promising. I only saw it for a second this morning. Lots of 3.3 and 5 volt systems on modern cars. Yep. A 48 volt car could look perfect for Toyota if someone wanted to look perfect. It could look perfectly Toyota if someone wanted it to look perfectly Toyota. It wasn't tech that made the Cybertruck the way it is. I mean, you say that, Pontius. Yeah, I see what you're saying for sure. Also, at the same time, where's the 48 volt Toyota Crown? You know what I mean? Just because it doesn't need to be electric to carry 48 volt architecture. In fact, I would contend to say that an internal combustion engine car with a high load alternator running 48 volt architecture would be very useful. But that, once again, that would require redesigning your starter motor, for instance, to be able to work on 48 volts. So now you got to go redesign a starter motor. That would require redesigning every single electronic component to be able to take 48 volts. That's a big deal. Now, when you're starting from scratch, like with Cybertruck, then it makes sense. But you're not going to see Ford or Toyota retool, an existing production line and existing supply chains for 48 volt architecture, because that doesn't make sense. The existing production lines are going to get you what you need, but they do make a more complicated vehicle. But you already did it. You already invested in it, right? Like, that's why I don't think we see 48 volt Toyotas or Fords or whatever. I think it's a good idea. I think all vehicles should be 48 volt. I'm saying that as an internal combustion engine snob. I think that's a good idea. EJ, in your free time, you should listen to Elon on the call. It's pretty good and is on point with what you're saying. Cool. All right, Pat. Yeah, like I said, I've been following Elon for a long time. What I try to do, guys, I keep my opinions about him to myself, good or bad. I try to just explain the play and go from there. And I try not to kiss his tail too much, you know what I mean? I really like SpaceX, though. I'm sorry. I think Starship is super cool. Sorry. But I also love SLS for what it's worth. Like, I want more rockets. I don't care what the avenue is. I want more of this and I want more of that. See that right there? I want more of that and I want more of that. And see this? This is a picture of an RS-25 at the press site. See Slick 36 behind it? I want more of that too. That's Blue Origin's pad in the background over there. I want more of that, please. Where's he going with those golf clubs? I think that's a camera. Alpha is vertical on the pad and getting ready for our static fire ahead of the Stairway to 7 mission. Check out our merge store to pick up Flight 17. All right, Stairway to 7. That's a good name. And more Slick 41. I just want more rockets. Because I do, and once again, this is where, I just said this about opinions. This is where I agree with Elon. If we want a moon base, one launch a year is not that. That ain't it. All right? With NASA, maybe 4 launches a year to rotate crews off of a moon base. But how are you going to get the crew there? Or not the crew there. How are you going to get everything else there? You're going to need a workhorse rocket. we want to spread our fingers out into the solar system. We want to do something like that. You're going to need to set up the industrial pipeline to get there. You need a form of transportation, something akin to, 500 years ago, a sailboat, or 200 years ago, the railroad, or 100 years ago, the automobile. You need an avenue of transportation to get you there, and that usually involves making a lot of it. You go back to the 1400, 1500, 1600s. The sailboat is king. Three-masted schooner, baby. Like Columbus and Magellan and the Pilgrims with the Mayflowers. Actually, the Mayflower's a really small ship for what it's worth. You have to be out of your mind to sail that thing across the Atlantic, but they did. You go to the golden age of the West, in the United States, like the whole Manifest Destiny thing. And I'm not saying you have to agree with that or not agree with that, but the railroad is king. The Iron Horse, right? That's a huge deal. The Transcontinental Railroad. Forging the infrastructure and the avenues to get there is how we do this, and that requires a lot of mass production. And the same applies to spaceflight, because spaceflight is just, rockets are just another form of transportation. They're just a thing to get you there, just like the train is a thing to get you there, or the airplane is a thing to get you there. The car is a way to go from point A to point B. It's just another logistics mechanism to move things around. And if we want a civilization on Mars, if we want a civilization on the moon, we want to have a moon base, we want to have a moon city, we want to have whalers on the moon that carry a harpoon, you're going to need a lot of rockets. It's pretty straightforward stuff. Are you saying NASA should be part of the Department of Transportation? No, Jim, not at all. I did not agree with Sean Duffy on that. In fact, I think that was one of the dumbest things I've ever seen anyone at NASA try to do ever, period, full stop. NASA okay, let me organize my thoughts for a second. Okay, so NASA is not a transportation company. They are not Amtrak. They're definitely not the post office. NASA, what is NASA's goal? There's a scientific research arm of the government applying to aerospace and spaceflight technologies. That is what they do. It's a research institution. Okay, I'll give you an example. I know I just said that NASA isn't like the post office, but they are. I mean, they aren't. It's specifically different. NASA shouldn't be operating like that. NASA should be working on the cutting edge. They should be working on new spaceflight technologies, like the stuff that Jared Isaacman talks about. They should be on the cutting edge. They don't necessarily need to build their own rockets, but I still think it would be better to build their own rockets. It would be better for NASA to keep operating SLS. I think that's more tenable for NASA in the long run, rather than relying on companies who hitch their, wagon to AI and could potentially burst the AI bubble and ruin NASA's plans. Because NASA is inherently a scientific research wing of the government, right? They're going to need a vehicle that's not like a regular vehicle. And like I said, I know I just compared them to the post office, but the Grumman LLV, does anybody know what that is? Grumman, the same company that made the F-14. You know what a Grumman LLV is if you live in the United States. You see one every day. It's that. That is a Grumman LLV. It's the post van, right? The mail cat, exactly. It's really funny because Northrop Grumman was producing this at the same time as an F-14, which I think is still hilarious. Diversifying revenue streams, baby, right? So, why do I bring up the LLV? I have a Ford F-250 out in my driveway. The F-250. You guys have seen it. Right? Does the LLV do what my F-250 can do? Yes, they're both vehicles. They both go on the road. But could you use an F-250 as a mail van? Yeah, sure. Why not? Would it be the best application? No. The reason why is because the post office has a very particular task that they're trying to accomplish, right? They have a very particular task that they're trying to accomplish, just like NASA has a particular task that it's trying to accomplish, right? Would a post van make a good daily driver? Hell no. It would be the worst daily driver around. It is a crappy, uncomfortable ride. It's not really designed to go fast. It's not designed to go long distances. It is quite actually a Chevy S10 with an aluminum chassis with an aluminum body on top of it. It rides like a frigging tractor. I talked to my postman. I asked him about it just to humor myself one time. It's not a good vehicle. It's good at delivering mail, and that's about it. Right? That's it. It's good at delivering mail. It has no air conditioning either. Now, how does this apply to SLS? This applies to SLS because NASA is doing a very specific task. That task for scientific exploration and understanding is not necessarily about logistics with rockets. That plays a component, just like my F-250 outside does the same thing that a mail van can do, and you can use one to do the other, but the LLV is suited for purpose. It was built for that. It was built for a very, very specific need. And I think that NASA, being a research arm of the government, has a very specific need when it comes to rockets and the applications of scientific exploration. So, Jim, do I think NASA should be part of the DOT? Hell no. No way. That's not what they do. It's not about logistics with NASA. It's not about delivering the mail, right? To use the mail van analogy again. It ain't about delivering the mail. That's not what they do. Their rockets are designed for scientific exploration. Their rockets are designed to do things that the commercial market really doesn't want to do because it's not profitable. That was the whole impetus for NASA existing. To pioneer technologies that no one else has. Now, I know what people are going to say. What do you mean? We've gone to the moon before. Yeah, but is there any market for that? Is there any market to go to the moon? No. There is no market to go to the moon. Yeah, everybody says that SLS is, 1970s technology. Yeah, it might be 1970s technology, but that technology is being applied to provide a very distinct scientific service that it doesn't make sense for the commercial industry to use that. Right? Would Elon ever try to build something like SLS? Hell no. He would try to build something like Starship, because for commercial spaceflight, logistics is key. Think about SpaceX in the future basically being the UPS or the FedEx of space. That's where they're positioning themselves from a spaceflight architecture standpoint. What happens when we need to deliver mail to the moon? Well, geek, you design a special rocket that's purposely built for logistics, or, well, at that point, you could just use commercial. But for doing NASA's actual scientific missions and exploration, dude, something like this makes perfect sense. NASA doesn't need to launch hundreds of times a day. That's not what they're about. They're not about logistics. And also, I know that was a joke. Screw you. Man. Hey, beautiful. I actually think Oh! I know what engine that is. I've stood in front of this engine. I saw this engine at Intrepid. Yeah. It's got the tags, the Rockwell International, or not the Rockwell International. It's got the Aerojet tags on it. See that plate on the low pressure pump? I've seen this motor before. I stood in front of it. Look below. Get a shot of the injector, I dare you. Oh, yeah. Yeah. Hey, baby. That's wicked nice, dude. Yeah, cone injector. Very 1970s. Hell yeah. The shuttle engine is an ITAR, dude. Don't worry about that. Max and Jack are just being jerks. Yeah, see? Look at the injector. See how there's little slits in the injector? That's designed to spray. Once again, who was paying attention when I talked about it? What are the injectors designed to do? What did I say is really good for a rocket engine to get a more efficient burn? Who was paying attention? Just out of curiosity. Atomize the fuels, baby. You got it. Good. All right. Sometimes I need affirmation to make sure that I'm not screaming into the void. Spread it out. See those slits? Those slits are designed to spread it out. And I forget if that's an oxidizer or a fuel injector. I think because of the ratio of hydrogen to oxygen, I'm pretty sure those are LOX injectors, and these ones with the holes in it are hydrogen injectors, if I'm remembering correctly. I could be wrong. Yep, atomization. You guys got it in both chats. Sweet. You said something? Right. Actually, some of those... So, guys, I'll tell you this. This rocket engine has not been fired in an extremely long time. The injectors are all gummed up and rusty. Like, yeah. This engine has been stored outside. I'm definitely seeing some corrosion around the rim of the injectors. This engine is old. This is old tech. That's why you can take a picture of it. This is a 1970s engine. This was if I'm remembering right, I've stood in front of this engine. It's a test mule motor that it never flew. It was an engine that they used for development in the 70s. They may be actual beehives in the beehives. It would fire once. Impingement on an injector is not a good idea, drummer. I don't even think you'd get to firing once. I think you'd get to explosion real fast. But also, woof. What is the insect that nests in airplane pitot tubes? Mud wasps. Dirt daubers. I mean, amongst other things, there's probably more. But see the rim of the nozzle? See how there's an impingement? How it collapses in on itself right there? Yeah, that's because they tried firing them without this last ring piece in the 70s, and they kept blowing up because of flow separation in the nozzle. It's flow separation due to... They had flow separation in the nozzle due to overexpansion. Overexpansion is the rocket science way of saying the nozzle is too big. But that nozzle has to be like that to be able to work up there and down here. It has to be that shape, or else, yeah, it won't work up there or down here. Looks extremely complicated. I'm telling you, man. Rather, that expansion ratio and that impingement architecture and their cooling architecture that they use for the RS-25, still cutting edge to this day. The design is still really good. The manufacturing has since moved on a little bit, but that's what the RS-25E is all about. It's basically a modern version of a shuttle engine. Yeah, that's what it is. What's launching today? You missed the Starlink already. Starlink 2 hours ago. We also got at 8 o'clock, we have Bridging the Swarm, so an Electron launch. And then at 11:30, we have Starlink 6-101. So there's 2 more launches today, which is why I'm doing space news kind of early, because we still got to have some time to play some games, dudes. Got to get that car driving around in winter car. Got to do that shakedown, man. Depends. The team tried to clog some of the injectors for the AR-22 and it still worked. It had a modified startup sequence to purge the injectors and combustion chamber before startup. Did you see that Section 4 or 5 of the Artemis 3 core stage has been stacked already? Yeah, binary. SLS stuff, now that they got funding out through... The one big beautiful bill put funding on the books for like the next 4 or 5 Artemis missions. You should start to see SLS stuff come around, SLS hardware come around real quick. You were in the middle of dissecting a worm for a lab practical, so I missed the Falcon launch. Yeah, that's cool too. Is that Max on the live stream? He was on the live stream at some point. Give me 1 second. All right, sorry. Bill Sloss is posting about shuttle engines in the back channel and it for NSF, and I sorry, when he posts something I listen because it's awesome. They left an RS-25, take it. I've actually touched that engine in Mana for what it's worth. Don't tell anybody. Get him on here? Nah, we're good. We got Winter Car to play. Let's do it. So that's going to do it for the Starlink coverage and borderline space and rocket review. We'll do more kind of intermittent space news laced in with the next 2 launches, because we got an Electron launch that's bridging the swarm that is at 8 o'clock. So that's 7 hours and 15 minutes. Or no. It's not 7 o'clock. That's 5 hours away. And then Starlink is 8 hours away. Actually, it's closer to 9, but that's fine. So, I'll see you guys all over for Winter Car here. I hope you enjoyed the Starlink launch and rocket review thing. And tech review, even though I don't know anything about tech. So, I don't know. Is this something you like? If you want me to speak my opinions about tech or something like that, or you want me to stay in my lane, you guys let me know. Okay? There's plenty more space news happening today, Dragon. Don't worry. You touch the engine? I don't know. I have no idea. I don't know what you're talking about. I don't recall these events at this time. I gotta go. Bye. Okay, I'm just cycling the YouTube bot over to Winter Car. Yeah.